Okay, this is question 6 of the practice control test. It's an inverse function question. Okay, here we go. We've got a function, f of x equals root x, and we've got restrictions on this function. We've got just x is greater than or equal to 0, so we're just looking at the positive x values here. Okay, here. That's the restrictions on x. Okay, let's try this. Now, we've got f of x equals root x. What you do, your first step, if you're supposed to find the inverse in the form y equals, first write it as y equals root x, and then what do? You switch x and y. That's your first step. And then you square both sides, and you get this function, y equals x squared. Y equals x squared. But y equals x squared, well, that function, y equals x squared, is just a parabola. It looks like this. But we've got only a certain branch of it. We've got the branch where x is greater than 0. So 0 and 0, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, it'd be up here. That'd be the kind of shape of it, a parabola that goes through like that. That's the inverse function. And it's set in the form y equals, so I guess y equals x squared is your answer for the inverse function. The function itself, y equals root x, we can get a sketch of it by just switching x and y. It's got to be 0 and 0. Switching, if we switch 1 and 1, we get 1 and 1. They must cross right there. And you know that if you had a point on the first function, if you put 2 in there, you get 4. Well, if you put 4, if you go 4 along, you get 2 up. It's kind of like a sideways parabola here. But it's the positive square root of x. It's this positive branch out here. Oh, and there's one thing that I forgot to put in. Let's put it in right now. It's the axis of symmetry. Include any axis of symmetry. Well, the axis of symmetry, I'm going to make it in a solid green line going right through here and going right through that one. That's the axis of symmetry. And you can just put it right through there, and then you could label it, or you could give the equation of the axis of symmetry, y equals x. And that gives you the equation of the axis of symmetry. And there it is right there. I've labeled the axis of symmetry, and it's that green line that goes through the middle. You see, the axis of symmetry is like a mirror. And if you have a point on this side, it gets reflected over on this side. This thing didn't quite work. Oh, yeah, about there. I didn't make it so nice, this axis of symmetry. Let's put it like, ooh, there's a bit, oh, that's a bit better. So if you have a point here, it gets reflected in the line over here. It's like a mirror. And the perpendicular distance on either side, you look in a mirror, you see yourself on the other side, the same perpendicular distance away. Well, that's what happens with the inverse functions. They get reflected about the line, y equals x. So I guess that's about it. The red one's f of x, the black one's the inverse of x. And that's how it works.